So our next speaker will share his knowledge accumulated in evolution. He's also from evolution that is organizing this event. As you've noticed, he will be sharing his special approach to building applications, and he's going to show the inner layer of implementation of event sourcing applications. So his topic is related to streaming data, to integrating services, and as well as storing data. He's the person who provides services to game developers so they can develop games easier. Physicist by training, yet software engineer by craft. So please welcome our expert who's been in Scala since 2013. So that's also around anniversary and a decade. So welcome warmly, please, Mikhail Sokolov, Scala developer from Evolution.
Thank you. So the microphone is working, yeah? You can hear me, right?
Yes.
Oh, that's perfect. Okay, hello to everyone. Dzień dobry to everyone. Yeah, I got to flex my 30 lessons of Pimsleur Polish, which I took 3 years ago. So that's the only thing I remember. Yeah, our talk today. So yeah, as was said, so we'll talk about event sourcing. It's more like architectural talk. Rather than I will not be showing a lot of Scala code. I think I have one slide with 3 lines of Scala code. So, but it's related to Scala by the virtue of most of the things I will be talking about are written in Scala, but they are not Scala specific, so to speak. So still, I think it should be interesting for a lot of people in the audience if you are a backend developer, so you somehow related to that field. Yeah. So let's not dwell on this Kafka Journal. What is it? So by the end, I think you should know what's going on. Yeah. So I work for Evolution, as you already understood. We do games, and more precisely, we do live casino games, and not only live, but in RNG casino games. So it's all about the games. We had a lot of teams which produce games. They work separately, but there should be some common architecture and infrastructure for building games more easily. So I will talk about that. Yeah. So yeah, I inserted this slide in case it wasn't presented before. Yeah. So my journey started from. Yeah, I studied physics. Then I switched to being a Java enterprise developer. So I worked with Java enterprise stack, several kinds of Java enterprise stacks. I worked with Spring. I worked with Java enterprise beans version 3 something, 2 something. Yeah, it was a long time ago. Yeah, and then I switched to Scala around 2013, and I wouldn't say I never looked back, but yeah, I'm still doing it, so it must be good, yeah. And I'm working for Evolution since 2016, so it's been more than 8 years. Yeah, so what I did and what kind of experience I had in the company. So for the most time, I worked on a inner service, not the game service, but the supporting service for other games so they be able to share the financial information to the outer world. So integration with the different, not the payment system, but other systems which needs to receive information about how much money was spent and the bets and stuff like that. And recently I actually switched to the new team which supports this common event sourcing infrastructure. Yeah, and with the before we go into event sourcing part, so a little meme, a little rant. Okay, so yeah, I want to ask the audience actually, please let's like do a little like impromptu quiz. So please raise your hands and stuff. So who can like consider himself a backend developer working mostly in Scala? Please raise your hands. Okay, almost all. That's good. So out of those, who are using mostly Cats effect stack? Okay. And who's using Zaya stack? Oh, yeah. Who is using Akka 2.6 or earlier stack? Okay. Well, don't lie. Really? Okay. And who is using new Akka stack, like post the license change? Okay. Even more than Akka 2.6. Interesting. Okay, so but most of you are Scala backend developers, so I guess you're in the context of this situation with the Akka licensing, and so basically around version 2.6 they did a stunt on us and changed the license from an open source license to a sort of closed source license, and basically if you with any Akka version post 2.6 like 2.7, 2.8, you have pay to use it in a bigger company, and the prices are not reasonable. So that was a big oof. So I just I took chance to get a job at them because it was bad. It's not good. So yeah, but inside Evolution, we, as you saw, I joined Evolution around 2016, and I think there were already some Scala code by that point. So our Scala code is it's quite old. In some places it's ancient. We try to update it, but things, especially dependency-wise, might get hairy. So we have many layers of different kinds of stacks, libraries, and stuff, and we have to keep them working together. And Akka 2.6, so it was maybe 2.5 back then, 2.4. It's still part of the equation, and actually. A lot of things work on top of Akka 2.6 deep down below. Even if people who writing games, they don't see it on top, it's still it's so you see nice Cats effect code pure and stuff, but deep down you have still Akka 2.6 running. Yeah. Just a little detour into the Akka and the Akka persistence and event sourcing, so we are more on the same page. Yeah, so actors, it's a pattern or model of how you structure your concurrent code. It's been there for quite a while. I think for some time it was getting traction in the Scala world, but then it subsided, so now it's not as fancy. But still, I think it's fair to. I like to mention the cases where you actually don't expect to see actors. So Akka, yeah, it's expected because it's Akka, actor framework, and we in Scala world we hear about it. But actually, it's interesting. So out of those who write in Scala, are there people who never heard about Akka before this talk? Oh, okay. Yeah, yeah, that's good. So, for instance, there are places which are built on top of actor patterns, that are actor systems, let's say Rust Actix framework. Unless they change something drastically inside their implementation, since 3 years ago, I think it should be still built on top of actors. So I don't think you can see it when you use it, but underneath it runs on actors. Yeah, Erlang is basically is obviously a poster child of actor pattern. So it's the thing which made it famous in the not in the scientific world where people make theories about how to write code, how to structure it, but in the real engineering world. And one of the things also interesting is Tarantul. It's a database in-memory database, and it's also written in C++, or I guess it's C++, not C. And it also is based on actors and actor, like internal actor framework. So it's like, it's quite common. Okay, so event sourcing. Well, I think if you read a little bit about like cool approaches to new approaches to writing backend code, a little like 5-6 years ago, maybe 8 years ago, event sourcing and CQRS like was all the rage, especially for Microsoft. So it was quite popular. So just a little explanation, what is it about for people who don't know. So basically, you build your system based on special things. So for Akka persistence is implementation of event sourcing on top of Akka, so it's like it's part of Akka. And they are sort of like a state machines which persist. There's like state transitions, they events into some external storage. And basically, when you build your application on top of that, you need to structure it in like those families of persistent state machines. Yeah. And what's also important for later talk is that actors produce events. For each persistent actor, like events form a linear history. And like altogether, all the events saved for like a family of actors, let's call them a journal. So, okay. Yeah, but you might notice that the description for persistent actors, which I showed before, it only mentions the things which are related to sort of like the right side of the equation. So you receive commands, you write events, and then what you can do also, you can recover like actor when it stopped, so it reads the journal again and sees the events. But what if you want to do, what if you need like more involved reading patterns? So you're not only like starting actor by persistence ID, but you need like some kind of aggregation of events from different actors to build some kind of representation, let's say an admin UI. So like you have a lot of persistent actors. Each of those is a transaction, like money transaction. And you need to build a report at the end of the day, which says like how much money went through. Okay. So for that thing, we use something called projections. So you take the journals and then you build something in database, and maybe the same databases where you store events, maybe different database. You build a special like separate representation which might have different querying patterns. So not only by ID of the entity, ID of the persistent actors, but like different kinds of IDs. And for our case, what we do usually in evolution, that read side doesn't have to be strongly consistent with the write side. So let's say, well, the same example as with the building the reports. So you need to have a report consistent by the end of the day, but you don't need to have it consistent all the time in each point of time. So it doesn't have to be like immediately consistent. Yeah. The thing which Akka persistence provides for this functionality is called Akka persistence query. Yeah, and basically it gives you a way to read the journal in some in chronological order, and for performance, you don't want to have like one big stream for all the events in the system, but you want them sharded, so you can like split the streaming. But as you noticed, it doesn't give you a way to, so you can only, so it gives you a way to read the events, but not the build the projection. So out of the stream, you will need to build the projection yourself, but it's like it's building block for that. What we used before, there was like the Akka persistence. It doesn't depend on specific database. So there were several. The things were called plugins, which were actually like working with the real database underneath, like saving events, maybe reading events, and we used Cassandra Journal plugin. I think it was started separately from the main Akka project, but then it was merged in. And people who are familiar with Cassandra database and its properties, you can see right away that writing to Cassandra is fast, writing to Cassandra is convenient. It will be, I don't know, like 1-2 orders of magnitude faster on like 99th percentile average than, let's say, writing to a normal database like Postgres. But the problems start when you want to actually stream events. So because what Cassandra gives you, you can write fast, you can read by the same like event ID fast, and everything else is torture, is pain. In different parts of evolution, we actually solved this problem differently. And in the team where I worked, we opted to use the built-in feature in the Cassandra plugin, which was available at that time, so in 2016, 2017, so quite a long time ago. For the event streaming, it relied on a feature of Cassandra, which was called materialized views. And yeah, then happened this. Okay, so they were considered production ready for some time, and then they retroactively marked them experimental. And I think now you have to supply special options to start Cassandra to to use them. So you can imagine how bad it was. Yeah, I have my little beef with Cassandra team because of that. I mean, not like they know about that, but it's more like me hating them, like projecting my hate to them. Like, so as I understood the issue, so the feature was poorly built, and I'm not sure why they marked it ready for production. But then when they understood that like it doesn't work well together with other features of Cassandra, it was they did this. Yeah, they pulled a sneaky one on us. Yeah. Okay, so the Cassandra plugin developers, actually, they reacted quite quick, and they rolled out their own implementation of event streaming. So basically, what materialized views did, they gave you a way to build a separate table, which was built on top of the first table with events, but with different IDs. So yeah, you can see the point. And the Cassandra Journal developers, they did the same thing, but manually, and the algorithm was not well described anywhere. And I checked the code several times, and I couldn't understand it. And I decided myself that I don't trust it very much, because thing with the projections, imagine you are building like financial reports, and if something is missing, and if the algorithm for replicating from one table to another is not solid, and you can lose something in some like corner cases, it's not good. So people will come after you, regulators will come after you. They will like shake you and say like and tell you like where are the cents, like why 1 cent is off, like and stuff like that. It's not good. You don't want to be in that situation. You want the thing to be rock solid, eventually consistent, but consistent eventually. Okay, yeah, and because materialized views were poorly integrated inside Cassandra, there were bugs, a lot of bugs, random bugs. Event losses, yeah. Tables stuck on different internal Cassandra procedures, yeah. So, for instance, like the guys who manage Cassandra, they tried to do some maintenance on tables, and it went wrong completely, like outage, nothing works, they need to restore data, stuff like that. It's horrible. And also the delivery latency was bad. So because I think we had like several minutes delivery delay, which was expected. So because of that, we could not use it for cases when you need like to build something like 10 seconds, 5 seconds after the fact. Yeah, what else was considered? So let's say, so people, please raise hands who heard about change data capture regarding databases. Okay, so I need to explain a little bit more. Yeah, okay, so it's a pattern of working with databases. So some databases provide this functionality, some do not. So basically they give you a way to stream to read the stream of changes to a table and do something with it, like build representation, put each change into Kafka, Kafka queue, do something with it. And Cassandra on paper provided this functionality, but yeah, it's my another beef with Cassandra. Yeah, it looked good on paper, but it was unusable. And the worst part, so let's start with the funky part. So the integration, basically you had to use Cassandra code to read its like commit log. Commit logs is like the files which Cassandra writes before like writes propagated anywhere else, and the format is not documented. There is no like separate libraries to do it, and your code which will do it, which will like read the commit log, it will have to be so you will have issues with the dependencies because like Cassandra code expects like one version of Guava, and your code might transitively use another version of Guava. Also, the data is duplicated. So, for instance, if your table is copied, you have copies on 3 Cassandra nodes, you will stream it to Kafka, you will have 3 copies in Kafka, and you need to do something with that, like deduplicate or something. And also, delivery latency was unpredictable, and this was a deal breaker, at least for me, because Cassandra couldn't guarantee. So if you do it right, it's confirmed. The Cassandra had no strong guarantees, after which time you will see the write in this change data capture. And it was related to internal implementation of commit log and stuff, so I don't want to get into that. Cassandra 4. Cassandra 4 actually improved CDC, improved implementation. So the worst part about unpredictable delivery latency is fixed. But everything else, okay, it gets a little bit funky as well. So they provided a like radius solution, which they say works. Well, who knows? But it's built on top of Apache Pulsar. It's a like queue. So we use mostly Apache Kafka. It's a queue. Apache Pulsar is a queue. We don't need to have like both of them in our system. So if we want to have a CDC-based solution, we want to have a CDC-based solution which goes to Kafka, not to Apache Pulsar. Like, why do we need another database for that? So as I understand, the implementation goes like this. So they still have this code, which is like just taking apart the code of the Cassandra database itself. They build it into an engine which reads the CDC, then streams it into Apache Pulsar, and there is another piece of code which takes it from Pulsar, duplicates it, and puts it back into Pulsar. So you can understand it's quite a lot of indirection. And if your data volume is big, so for instance, if you need to maintain Kafka cluster for this thing of like 15 nodes, then on top of that, you will need another cluster of Apache Pulsar, which might have like 20 nodes, and you basically doubling your expenses on this thing. Yeah, so what we came to is called Kafka Journal, and yeah, we basically combine together Cassandra and Kafka. We write events to Kafka, which is a bit slower than writing them to Cassandra. Well, let's say average write to Cassandra on premises might take millisecond, 2 milliseconds. So average write to Kafka on prem would be around 20, 30 milliseconds and like maybe 50 milliseconds. So it's bearable, but like, for instance, if your logic for a game is built like that you write a lot of events, then they might like stack up and you might end up with big latencies. But so far it wasn't a problem as far as I know. Yeah, and then to improve the reads, so you cannot read from Kafka by ID. So Kafka is just a queue, and it's quite dumb of that. So there is no like queuing by individual identifiers. You only queue by topics, and topics are big. Well, they split into partitions, but that's not important. And then we have a separate service which takes the data from Kafka, puts it into Cassandra, and we do the reads from Cassandra. Then you might ask, like, what about the consistency? And yeah, we solved that problem, but it's involved. So if you want to know more about how we maintain consistency, there is another talk. I will give you a link in the end from Yaroslav Klimko, who was the original developer of this solution. And it goes more into details. But one of the interesting thing which I want to note is to ensure consistency, one of the tricks is that we promote recoveries to writes. So basically reading is also writing to Kafka. And I think some databases, they use the same trick as well to maintain strong consistency guarantees. That's interesting. And you can see the overall design got to be a bit like a fractal. So let's say Cassandra, how it works on top level, so the storage. When you do write, it goes to commit log. Commit log is just like, I insert record 1, and then I insert record 2. It's just the information about what changes you did to the system. And then it's sort of like a queue, if you think about that. And then from commit log, they are replicated by a separate like internal process of Cassandra to an indexed storage, memory table, disk storage, which is easy to read by IDs. And we do the same with Kafka Journal. So Kafka is our commit log, and we replicate it to Cassandra for efficient reads. Quite nice. Kafka Journal, so what is it? The code is on GitHub. It's sort of open source, but there are pieces which are still missing from the open source solution which we have there. And it's not because we're like evil, because of our like malicious intent, but only because we're a bit lazy. So, for instance, I don't think you could use it right away if you take it from GitHub. It's not well documented, and there are some like pieces missing. It's written in tagless final. Big round of applause, please. Like everything is in tagless final. It's quite a feat, especially for like, it was written mainly by one guy. It's like pure like Scala 2 cats effect, and yeah. Let's go a bit further. So the interesting part, lessons learned with all that stuff. I want to highlight like one two like interesting problems which we had. Binary compatibility is a bitch, is a problem. Especially in big organizations like Evolution, and we have a lot of separate repositories for services. We have a lot of separate repositories for libraries. They all depend on each other. They all built in different times. They have different sets of dependencies. They are updated at different times in different pace. Something is not updated well, and it gets really, really hairy. So keeping it all together, it's hard. Let's say there was an update from Cats Effect 2 to Cats Effect 3. So basically, as long as there is like any pieces of code internally which depends on Katz effect 2, you will have like split your implementation on this axis. And the more axis like that you get, the harder it gets. It's really bad. So my plea to Scala developers who do libraries, please do not break binary compatibility. Please, like keep it as much as possible. Yeah. Yeah, and another interesting lesson is that storage is actually, it grows and you might run out of it and it's expensive. So when people were talking about event sourcing, they usually never talk about where you put the data when it's not needed anymore. So you just write data, you write events, events are like the data is new gold. No, the data is, it's not an asset, it's a liability. And a lot of data is a big liability, it costs a lot. And people don't tell you about that, so you need to plan for that. Yeah, and a lot of solutions which are built for event sourcing, they are not built with data retention in mind, and data retention is usually an afterthought. And you might make some decisions in the beginning of your project regarding like how you split your entities, persistent actors, which might make removing data later very, very hard. So please plan for that, think about that from the start. So like at least like a little bit. But maybe usually when you just start the project, you don't have a lot of time to think about that. Like you need to deliver solutions, you need to earn money quick, but yeah, like just a little thought about that, yeah, that would be good. Yeah, so I will go to the end, so I have like a couple minutes for questions. So the links, I think if you really want it, you can like take a picture, but I can give slides later, and so you can copy it. What I need to highlight, so the Kafka Journal repo, the Yaroslav Klimko talk, so it's like 1 hour long, and it has more about this consistency thing. And please, let's all migrate to Pekko from Akka 2.6. Pekko team is new, like, so they basically fork the Akka 2.6, and they keep it open source, and they are really cool guys. So let's support them. About Cassandra storage architecture, about commit logs, where the data from commit logs comes after, and about Kafka and what it takes to keep consistency guarantees and Kafka replication protocol. If you're interested, please check out the quite old but still relevant report about testing of Kafka replication by Jepson project. I don't remember, Kyle Kinsbury, I think the guy. Please read it. It might be a bit involved to read, but it's cool. Nice to read. Okay, I think that's all.
Definitely round of applause. Do we have any questions or any thoughts that you'd like to share, or you want to let me see? Yes, there's one here. Okay, you'll get the microphone so we can hear you better.
Just very small one. You mentioned in slide about snapshots. What's wrong with them? Snapshots.
Snapshots. Ah, okay.
Yeah. You mentioned, you didn't mention the speech, but in slides.
Yeah.
The problem with snapshots. What's kind of problem?
Problem with snapshots and Kafka Journal, and problem with snapshots in general. Okay, so snapshots are a trick to improve the read time, recovery times for actors, and in some cases reduce the storage costs. So you compress all the history of events for an actor into one thing, which is called a snapshot. But for this thing to work, it needs to work in concordance with like journal storage, and especially when you need to consider the data retention, because let's say you remove the events, but you don't remove the snapshot. You remove snapshot, you don't remove the events. The removal should work together. But for Akka persistence, I think in most cases, the snapshots in journals, they work separately. So in Kafka Journal, we addressing that at the moment, but I don't think it's open source. And maybe at some point we will like fix it completely and publish it, but still.
Okay, any other questions? Let me have a look beyond the light. All right, so if you have any thoughts later, of course, you can catch Mikhail during our networking after all our presentations for today. So once again, big round of applause. Thank you very much.